Hello, this is our presentation on malicious code by Jeremy and Claire. This is just a quick overview of the four vulnerabilities we will cover in depth. So the first one, SQL injection. This was first documented in 1998, and SQL injection allows you to inject SQL and execute any arbitrary SQL command that you could normally do on a database. So let's take a look at a demo that we have set up. So we made a Flask server with some HTML that we load in and a little bit of JavaScript. And we have a database file here. Um, so let's take a look at the login functionality where there's SQL injection in this line here. So the database is running. So if we load up here, we can see we have separate containers for the user profiles, which we'll use throughout the demos. So let's log out as Alice and take a look at this functionality. So if you supply an incorrect password, it'll just bring you back to the page, and only with the correct password will it allow you to log in and see your profile. So if we take a look at those requests using a proxy here, um, this was the incorrect password. It was just password. And you can see it loads this up, just a login page, and with the correct password, it gives you a cookie and actually signs you into Alice's page. So if we take a look at this request, the incorrect password, again, we can see incorrect password will give you this every time. But if we inject some SQL in by looking at this, we can see we're inside a single quote. And what we can do here is supply the correct email, but then inject some SQL in by closing the single quote and saying if the password is equal to this or 1 = 1, which is always going to be true. So if we take a look at what that looks like, we can say we can close the SQL, do or 1 = 1, and then comment out the rest of the line because there's a trailing single quote. If we send that now, we can see we log in as Alice, and we don't even need our own cookie. We can send this, and it will give us a cookie, which will allow us to send authenticated requests as Alice. So that's a SQL injection. The mitigation for that is going to be how we do it in most of the other places here, which is using parameterized queries. Most languages support some variation of this, where you can just supply where they're going into and list the variables, and it will safely put them in, avoiding string concatenation like we were doing. So that's a really quick SQL injection. Let's take a look at some XSS. This was first disclosed by Microsoft in 2000. XSS is just executing arbitrary JavaScript on a victim's browser. JavaScript in the web world is run client-side. There's three types. There's reflected, persistent, or stored XSS, and then DOM-based XSS, which is things like JavaScript URI or eval functions in JavaScript. And the impact here is a full account takeover. You can steal a cookie like we talked about here. Once you have a cookie, you can send a request acting as whoever that logged in user is. Or you can deface a page. You can inject HTML, redirect, prompt. There's some other things you can do, but the main impact is going to be a full account takeover. So let's take a look at that. We have a website here, which is going to look for any GET requests sent to this domain, and then we can log them. So we can actually steal some credentials. So if Alice logs in here, we have some stored XSS in the bio, that persistent XSS. So we paste in this link. This will update uh, her bio to be an XSS bio. And the bio also has these script tags. These are what we injected. And this is what's going to send a request to that website and attach the cookie of the victim. So if Bob logs in, this is Bob logged into his profile here in the green tab. If Bob logs in and goes to users/Alice, let's check Bob's cookie. Get profile. This is Bob. So Bob's cookie is this. This is what we're trying to steal, this EYJ1C2. If Bob goes to Alice's profile, we can see it loaded that script. And then if we check this domain here, the webhook, we can see we got a request and it attached the cookie on. So that's the UIJ1C2. So Alice can now see Bob's cookie and she can steal it and send requests as Bob. So mitigation of XSS, the most important one is going to be sanitizing user input and output. So that would be in the new bio field. It should be checking and making sure it's only safe characters. And then when it's outputting the bio into the HTML, it should also be encoding that. So you kind of want defense, it's called defense in depth. You want defense at multiple layers. There's policies to disallow JavaScript from accessing the cookie inside the browser or only accessing it from the same site. And then you can also have a firewall to detect malicious tags. This would be a JavaScript URI that would fire inside of an href or like a link. So those are different ways to mitigate XSS. And I will stop screen sharing and pass it over to Claire to talk about the rest of the exploits.
Yeah, so the next thing that we looked into was cross-site request forgery, or CSRFs. So these have been discovered since around 2000. And the main impact and idea behind this attack is that the attacker will force the victim to submit a request that can be completed because the victim has credentials and authorization that the attacker may not. So this can have them unknowingly perform sensitive authenticated actions. So looking into a demo here, suppose a hacker creates a link. And so this link has a malicious action in it, which is changing the bio of the user. And we can see here that in order to update the bio, it does require that the user is authenticated. So if we were to go in here, see we're logged into Bob, and suppose Bob goes in and clicks that link that was sent by the hacker, we can see here that Bob's bio is updated and it leveraged Bob's credentials to be able to complete this attack. So some of the mitigations for this would be really the main one is using a CSRF token. And so one way to do that would be importing CSRF Protect, specifically for Flask, since that's the platform that we used, and protecting the app. So tokens, for CSRF tokens, most modern web applications do have CSRF tokens that are generated and validated for every post request in that server side. And then in addition, making sure that GET requests are only performing like data retrievals would help to ensure that no unintentional sensitive actions occur. So now looking into the large attack that we were working on was the XSS worm. And so this infected MySpace in about 2005, which at the time was the largest social networking platform. This worm, discovered by Sami Kemkar, has spread to over millions of profiles in just under 20 hours, forcing the site to shut down. This sort of the main impact of this XSS worm was that it could spread so rapidly with no user input, and it really put companies on alert for looking out for these XSS and web vulnerabilities. So now we'll look into a little demo for the XSS worm. So we have an exploit.js file, which is going to be used in Alice's bio here. And then when other users visit Alice's bio, this entire line will be injected into their bio, which will result in the self-propagation of the worm. So let's take a look here. So first, we're going to update Alice's bio. And the cool thing about the XSS worm is that it really is a combination of both XSS and the CSRF vulnerabilities. And so kind of putting those together into one attack. So we can see here that we updated Alice's bio. And now we can see we're in Bob's bio or Bob's profile. And if Bob goes and views Alice's profile, we can see Alice's profile. And then if we go back into Bob's profile, we can see here now that Bob has been infected with the worm. And then if we want to go one step further, we can go look at Bob's profile from Caroline's profile, see that Bob has been infected. And then if we go back and look at Caroline's bio, we see that now the worm is propagated through both these accounts. So that's just a quick demonstration of how the XSS worm works. So looking a little bit more into the broad picture, obviously since 2005, the attack has been mitigated, but looking into other defenses, there is static code analysis. So this could be either manual or automated, looking into dynamic testing with penetration testing. And then there's also bug bounty programs. So instead of hacking and getting a felony like Sammy did, these programs are more to support ethically reporting bugs to help um, increase security across websites across the web. So thank you so much for listening.